Alrighty, let's look at option A first. A says call the analyze document API with feature types set to signatures and retrieve confidence scores per page. Analyze document with signatures extracts signature elements and includes confidence scores in the response. Looks good because that's what we are looking. We'll keep it. We'll now move to B. B says use the prediction API on the documents to extract signatures and confidence scores. Prediction API is not a part of Amazon Textract and doesn't support signature detection. What we need? B is out. Let's move to option C. C says initiate the start document analysis API to detect signatures and return page level confidence scores. Start document analysis initiates asynchronous processing, adding unnecessary complexity, which we don't want. C is out. Let's move to D. D says retrieve results using the get document analysis API and extract signature confidence score per page. Get document analysis retrieves results from asynchronous jobs not suitable for immediate scoring what we require. Let's delete this. We'll lock option E as the right answer. Okay, let's look at this question. This will test your concepts on SageMaker DPR. Option A says apply linear regression to estimate missing target values, then train DPR using full dataset. Linear regression adds unnecessary pre-processing and may introduce bias in time series patterns. Therefore, incorrect. Let's now move to option B. Option B says encode missing target values as NaN and use the dataset as is for DPR training. DeepAR natively supports NaN in the target field, allowing it to learn from available data without manual imputation. We'll keep it. Let's move to C. C says use forward fill to propagate previous values, then to missing target fields, then train DPR. Forward fill assumes temporal continuity, which may distort seasonal or irregular trends. Wrong answer. We'll move to D. D says fill missing target values with the mean of the series, then use the datasets for DeepAR training. Mean imputations flattens variability and weakens temporal signal integrity. We'll delete this. We'll lock option B as the right answer. Alright. Now let's look at this question. Option A says launch a separate SageMaker endpoint for the new model and use an application load balancer to split traffic between both models. Application load balancer requires external setup and adds infrastructure complexity. As per the question, we need to keep operational overhead low, right? So this is against the goal of the question. We'll reject option A. Let's move to option B. B says update the current SageMaker endpoint to include production variants and assign traffic weights between the old and new models. Production variants allow traffic splitting within a single endpoint, minimizing changes and overhead. Let's keep it. Let's now move to option C. C says reconfigure the current endpoint to use batch transform for routing traffic between the old and new models. Batch transform is designed for offline inference, not suitable for real-time traffic. What we need here, production traffic, right? So this is out. Let's move to option D. D says deploy a new SageMaker endpoint for the new model and use a NLB to manage traffic distribution. Network load balancer, that is NLB, lacks native integration with SageMaker endpoints for traffic aware routing. We'll reject it. We'll lock option B as the right answer. Let's bring the heat to this now. We'll first look at option A. Option A says use S3 with S3 cross region replication to store versioned image and replicate them across regions. Amazon S3 with cross-region replication supports auto-scaling, versioning, and multi-region access with minimal setup. Looks good. We can keep this for now. Option B says use Amazon EBS with snapshots to a snapshot shared to another region for backup and access. Amazon EBS snapshots are static backups, which is not designed for scalable versioned repositories. Therefore, wrong answer. Let's move to option C. C says use Amazon EFS standard with regional configuration to store image files with elastic scaling. EFS scales but doesn't support versioning or cross region replication. Incorrect. Let's move to D. D says use storage gateway volume gateway to sync on-premises volumes with AWS cloud storage. Volume gateway is designed for hybrid storage, not cloud native replication and versioning. We'll delete it. We'll lock option E as the right answer. Okay, let's look at this. Here the goal, we need to make sure the operational effort is low, and this will test your concepts on low maintenance document processing pipeline, where we have incoming PDF and JPG files daily. Option A says use a paddle OCR model in SageMaker to extract field level text and a SageMaker text classifier to categorize the documents. SageMaker requires model management and tuning, increasing operational effort. As per the question, we need operational effort low, right? So therefore this won't fit in. Now let's move to B. B says use paddle OCR model in SageMaker for text extraction and apply comprehend for document classification. Paddle OCR lacks native integration with comprehend, requiring manual orchestration. We'll delete this. Let's move to option C. Option C says apply textract to extract field level text and use recognition to classify the documents. Recognition is designed for image analysis, not text-based document classification. Wrong choice. Let's move to D. D says use textract for field level text extraction and apply comprehend for classification. Textract and comprehend are fully managed services, which reduces operational overhead while handling both extraction and classification. Looks good. We'll lock option D as the right answer. Alrighty, now let's look at this question. Option E says launch multiple model instances across a VPC spanning 2 AWS regions to ensure redundancy. Multi-region deployment adds latency and complexity, exceeding minimal effort requirements. Let's delete this. Now let's move to option B. Option B says enable SageMaker auto scaling to adjust model capacity based on traffic. Auto scaling adjusts capacity but doesn't protect against availability zone failure, which is the requirement here. Therefore, wrong answer. Now let's move to option C. C says deploy multiple model instances across a VPC with subnets in 2 availability zones for fault tolerance. Deploying across multiple subnets in different availability zones ensures high availability and meets the RTO requirement without cross-region complexity. We'll keep it. We'll move to option D. D says regularly create model backups and restore them in secondary region when required. Backups in another region requires manual recovery steps, which will delay response time, which we don't want, definitely, right? So D is wrong. Let's move to unlock option C as the right answer. Alright, we have a brainstorming question. Are you ready for it? Let's first look at option A. A says apply latent dirichlet allocation, that is LDA, to extract topics from each article, sum topic counts to score votes, and retrieve articles with higher scores for query terms. Latent dirichlet allocation, that is LDA, models topic distributions, not individual word relevance. Incorrect. Let's move to B. B says compute term frequency weighted by article length and inverse document frequency across the corpus. Use the product of both as relevance score to rank articles. Term frequency and inverse document frequency captures both local frequency and global distinctiveness, aligning with the need to rank words by relevance and importance. We'll keep it. We'll move to now C. C says use pre-trained word embedding table, average embeddings for each article title, and calculate a score based on the inverse of the embedding distance to queried words. Embedding similarity measures semantic proximity, not frequency or importance. Wrong answer. We'll move to D. Option D says generate a term frequency table for each article, excluding stop words. Use raw frequency as the score to rank articles for queried terms. Raw frequency ignores corpus-wide rarity, leading to overemphasis on common terms. So this is out. We'll lock option B as the right answer. Alrighty, now let's look at this question. This is all about SageMaker. Option A says launch a warm start tuning job that reuses insights from the previous tuning run. Warm start reuses prior tuning knowledge to reduce search time while adapting to new objectives and ranges. We'll keep it. We'll move to now option B. B says initiate a checkpointing tuning job to resume from a saved state. Checkpointing resumes the same job but doesn't support changing the objective metric. Wrong answer. We'll move to C. This is set the same random seed as the earlier tuning job to replicate sampling behavior. Using the same seed improves reproducibility but doesn't reduce runtime or leverage prior results. Wrong choice. You move to D. This is execute multiple tuning jobs in parallel to speed up the search process. Parallel jobs increase throughput but doesn't reuse prior tuning insights, leading to redundant exploration. Let's delete this. We'll lock option A as the right answer. Alright, now let's look at this question. This is all about SageMaker service while complying with no internet rule. Interesting topic, right? Option A, if we look, says use site-to-site VPN to encrypt outbound traffic from the VPC. Enable VPC flow logs to monitor activity. VPN encrypts traffic but doesn't eliminate internet exposure or enforce endpoint level isolation, what we need. Therefore incorrect. Let's now move to B. B says set up VPC interface endpoints for SageMaker and S3. Adjust security groups to allow outbound traffic only for training and hosting. VPC interface endpoints allow secure private access to SageMaker and S3 without internet connectivity. Looks good, we can keep this. We'll move to C. C says attach IAM policy that blocks internet access and assign it to SageMaker notebook role. IAM policy control permissions, not network routing or connectivity. Incorrect. We'll move to now D. Option D says create security groups that block all inbound and outbound traffic and attach them to the notebook instances. Blocking all traffic prevents access to required AWS services, stopping training workflows. So this is out. We'll lock option B as the right answer. Alright, now let's look at this question. This is all about SageMaker. Option A says tune the momentum hyperparameter to a higher value to stabilize updates. Higher momentum accelerates convergence but doesn't address overfitting. Therefore, wrong answer. Now let's move to option B. B says lower the dropout rate hyperparameter to retain more neurons during training. Lower dropout rate reduces regularization, which worsens overfitting. Wrong answer. Let's move to option C. C says decrease the learning rate hyperparameter to slow down weight updates. Smaller learning rate slows training but doesn't mitigate overfitting. Wrong answer. We'll move to D. D says raise the L2 regularization hyperparameter to penalize large weights. Increasing L2 regularization helps reduce overfitting by constraining model complexity. Looks good. We'll lock option D as the right answer. So please don't go away. Let's meet in next part of this series. Please check out my other courses on Udemy by searching Cloud Guru Amit, where I have tons of courses related to cloud computing, that is Azure, Google Cloud, AWS, cybersecurity, management courses, and many more. And also please consider connecting with me on LinkedIn at the rate of Cloud Guru Amit or Instagram at the rate of Amit Physique, where if you need any kind of personal assistance, I'll be glad to help you out. Thank you so much for watching this video. Please do consider sharing this video with your colleagues or friends so that they can also utilize the training program provided by NVIDIA.